Hi guys, in this video we're going to be learning about compound inequalities, which is an entirely new topic. So it is important that you make sure that you understand all the previous videos that we've seen. So in this first example, it says, in the previous lessons we have worked with inequalities that have just one restriction. So for example, if only people that are 16 years old or older may have a driver's license. So they gave you that example and they wrote A is bigger than or equal to 16, A being the age. Now in real life that's not always the case. Sometimes there's more than one restriction. For example, here they gave you the speed on the freeway. You have to drive, maximum speed is 70 and minimum speed is 50. So you have to drive somewhere in between there. So what we're going to do is we're going to learn how do we write this and what would it look like on a graph when you have more than one restriction. For the first part, we're going to say S is less than or equal to 70. So here is the 70. That's why they're shading everything else over here to the left, because you can drive less than 70. Then I'm going to graph the second part, which is S is bigger than 50, because that's the second condition that we need. So S is bigger than 50, so I'll go ahead and shade the opposite side. Now what we're going to find is that now that we have two inequalities that overlap, our answer is the overlap. So our final answer is from 50 to 70. Those are my solutions. You can drive between 50 to 70 miles per hour on the freeway and you won't get a ticket. So because both equations must be true and the solution set overlap, we can write this relationship as either two inequalities connected by the word and, or combine the two inequalities. This is called A and this is called a compound inequality. It's some terminology that you need to know. So we say S is bigger than 50 and S is also bigger than 70, or we can also say S is greater than 50 but it's also less than 70. Both of those are correct forms of saying the following information. Okay, so let's look at example 1. In example 1 they want us to write and then graph a compound inequality for the situation. So they say that the youngest person to graduate from Brownstone College was 16 years old. The oldest person was 72. So obviously, everybody else has to be between the ages of 16 and 72. So we're going to write that as a compound inequality. First, we're going to write the first one, which is that the youngest person. So the age is bigger than or equal to 16. So if I was to fill this out, it would be 16 and I would be shading everything to the right. Now for the second part, it's everybody less than 72 years old. So I can say that A is going to be less than or equal to 72 years old. So I start at 72 and it's everything to the left because it's less than that age. So where they overlap, I see that they're overlapping right here, is my answer. So my final answer is this. From 16 to 72, I shade in between there, and that would be all my solutions. A, which is the age of these people, can be greater than or equal to 16, but it has to be less than or equal to 72 at the same time. Go ahead and pause me, try it, and then see if you can find the right answer. So hopefully you were able to solve this. I first started by setting my variable. So I said G is the gasoline cost, and the lowest it ever was $1.50. So G has to be bigger than $1.5. Then it has to be less than 4.6 because that was the highest price it ever was. So G has to be less than 4.6. Now I didn't graph it, but I went ahead and made a combination of those two things. G has to be bigger than or equal to 1.5 but also less than 4.6. If I was to graph this on a number line, I would be putting at 1.5, between 1.5 and 4.6, I would be making a point and shading in between there. Why? Because everything greater than 1.5 would have been shading this way from this point, everything less than 4.6 would have been shading this way, and the overlap was from here to here. So that is my final answer. So it says the previous examples are compound inequalities that are written using the word and. The following example is an inequality that will use the word or. So let's go ahead and take a look. Graph the solution. X is less than or equal to 2 and and h is bigger than or equal to 5. So we have another kind of case. In the other examples, if you notice, we had an overlap and that was my final answer. Here they're going in opposite directions, so there's going to be a gap. So let's see what happens here. Now h is less than 2, so we put the 2 here, we shade everything to the left. Then h is bigger than or equal to 5, so I put my close point, shade everything to the right. And now we're going to say, okay, so what's my answer? My answer is both together. If I was to graph this, I would put a 2 and shade everything over here, and then I would put a 5 and shade everything over here. That's my final answer. There's a gap in my solutions because it can't be between 2 and 5 based on the conditions that were given to us. So it says here, notice that there is no overlapping region for the two parts of the compound inequality. This type of compound inequality should be written with both inequalities and separated by the word or. So h is less than 2 or h is bigger than 5. So now we're going to graph some triads. Go ahead and try graphing these. See if you can get them right. Go ahead, put pause. Okay guys, so hopefully you were able to solve both of these. For the first one, we first graphed that b is less than or equal to negative 13. I made it a closed circle. And then b is bigger than 10, and it's an open circle. So this is how the final graph would look like. And then for part b, I know it looks a little confusing at first because it's saying x is bigger than or equal to 36, but then x is also bigger than 48. Because the 48 is already included in the solutions for the second part, we just graph everything bigger than 36. 48 will be included in there. So we make it a closed circle, and it would be everything greater than 36. Okay, so let's go ahead and take a look at example 3. It says write a compound inequality for each graph. So what's it saying here? X is between negative 3 and 1. So x is greater than negative 3 and x is less than 1. Then places, you always are going to put the smaller number on the left and the larger on the right. That's the correct form to say. So you're not going to write, for example, 1 and then x and then negative 3. Although you're saying the same thing, we're not going to write it like this because this is the correct form of writing it, going from the least number to the biggest number. Then in the second part, we have here that x is less than negative 5 because it's shading everything less. Not negative 5, sorry, negative 3. And then x is showing here it's bigger than 1, 2, 3, bigger than 4. So those two things are, and if I was to write it combined, I would write this as, no, actually I wouldn't write these combined because these are going in opposite directions. So I would just leave it like that, separated. So it says, because they do not overlap, the inequality should be written separately. X is less than negative 3 or x is bigger than 4. Okay, go ahead and put pause, see if you could write these inequalities. Okay, so hopefully you were able to write these. For the first one, since it's between negative 1 and 6, we say that x is bigger than or equal to, remember it's a closed circle, so we write it as bigger than or equal to negative 1, and it's less than or equal to negative 6. In the second one, we have an open circle at negative 1, so I just say x is bigger than negative 1, but it's also less than or equal to 6. The bottom one, since they're going in opposite directions, we need to write them separately. So we say that x is less than or equal to negative 5, or x is bigger than or equal to 4. and that would be my final answer. So that's it, guys. Hopefully you guys were able to do okay on these.